Two snails move at constant speeds. If snail moves 4 feet in 5 hours and snail B moves 8 feet in 9 hours, which snail is moving faster? We're going to do this two different ways. First, we're just going to compare unit rates. That is how many feet per hour each snail is moving. So for snail A, they move 4 feet in 5 hours, which is 4 fifths feet per hour, 4 fifths of a foot per hour. And then for snail B, they travel 8 feet in 9 hours, which comes out to 8 ninths feet per hour. So 8 ninths of a foot every hour. And which one of these is faster? So 4 fifths or 8 ninths, which number is bigger? So we talked about how to compare fractions like this in our last semester course. 4 fifths is 1 fifth away from one whole, and 8 ninths is 1 ninth away. So this one is closer to one than this one is, which means 8 ninths is bigger. So 8 ninths is faster. If we put it on a number line, right here's one. Oops, sorry, that's 0 and 1. If we break this into 5 equal pieces, then we have 4 fifths about right here. And if we break it into 9 equal pieces, we see that 8 ninths is closer to 1 than 4 fifths is. So 8 ninths is faster. Snail B is faster. Okay, we could solve this problem in a different way using a table or a double number line. I'm going to use a table. So I'm going to have snail A and snail B, and I'm going to put time and distance. So snail A, I'm going to have time and distance traveled. So 0, 0, right? But then they go 4 feet every 5 hours. So in 5 hours, they've gone 4 feet. In another 5 hours, they've gone another 4 feet. So 10 hours, 8 feet. And in another 5 hours, 15 hours, they've gone another 4 feet, 12 feet. And we could just keep adding these in here. So go another 5 hours, 20, another 4 feet, 16, another 5 hours, 25, another 4 feet, 20. Maybe we'll do one more. We might have to come back and do more, but I'm just going to stop here. So 30 and another 4 feet would be 24. Okay, so there's snail A. Then let's look at snail B. I'm going to make a similar chart, time and distance, 0 and 0. Okay, so snail B goes 8 feet every 9 hours. So I'm going to put 9 hours, 8 feet. In another 9 hours, that's 18 hours, they'll go another 8 feet, so 16 feet. And in another 9 hours, 18 and 9 is 27. They'll go another 8 feet, that's 24 feet. 27 plus 9 more hours is 36 hours. 24 plus 8 more feet is 32 feet. Maybe I'll just do a couple more. 36 plus 9 more hours is 45. 32 plus 8 feet is 40. Okay, let's compare. I am either looking for a time that they have in common. So if we have a time in common in these two tables, I can say like, okay, in the same amount of time, look at how far snail A traveled and how far snail B traveled. Whichever one went further in the same amount of time is faster. Okay, so I have multiples of 5 here and multiples of 9 here. Oh, I have a 45. That is a multiple of 5. So I could take this out to 45 and see how far snail A has traveled, right? Or I could look for a common distance. Okay, if I look for a common distance, then I can look and say, okay, which snail went that distance in a shorter amount of time? Then that's the snail moving faster. So they do have a common distance of 16 feet already listed in the tables. So let's look at that. So snail A went 16 feet in 20 hours, and snail B went 16 feet in 18 hours. So snail B went the same distance as snail A, 16 feet, but in less time. It took them 18 hours versus 20 hours. So snail B is faster.